The James Webb Space Telescope is rewriting the history of the universe. In a stunning series of recent discoveries, NASA's James Webb Space Telescope, JWST, has peered deeper into the cosmos than ever before, revealing mysterious galaxies, stars, and cosmic structures that should not exist according to our current understanding of the universe. These findings are not just incremental advances, they are paradigm-shifting moments that challenge some of the most fundamental assumptions in modern cosmology. As more data pours in from Webb's sensitive instruments, scientists around the world are facing the possibility that our existing cosmological models may need to be dramatically revised, or even replaced. The rise of the impossible, galaxies that shouldn't exist. One of the most profound revelations from JWST centers on ancient galaxies, colossal cosmic structures formed mere hundreds of millions of years after the Big Bang. These galaxies, like the now famous GN, Z11 and Uncover, Z13, appear far too massive and mature for their place in cosmic history. GN Z11, for instance, is located approximately 13.4 billion light-years from Earth, meaning we are seeing it as it was just 430 million years after the Big Bang. According to the standard lambda-CDM cosmological model, galaxies of such size and complexity should not have existed at such an early epoch. The processes believed to form galaxies, gravity slowly pulling gas and dark matter into dense regions over billions of years, could not have built GN, Z11 so quickly. But JWST didn't stop there. In its deep surveys, another galaxy emerged, Uncover, Z13, located even farther back in time. With a redshift of Z equals 13.79, this galaxy existed just 330 million years after the Big Bang, during what cosmologists have long referred to as the Dark Ages of the universe. At this time, the universe was thought to be devoid of stars and galaxies, filled only with neutral hydrogen gas. But Uncover, Z13 defies this, already bursting with starlight and structure. These are not isolated outliers. What were once considered rare anomalies in Hubble's data are now appearing as common patterns in Webb's high-resolution infrared observations. This forces us to question a crucial assumption. Were the early years of the universe far more active and structured than we imagined? Chemical clues from the dawn of time. One of JWST's most transformative capabilities lies in its spectrometers, which allow scientists to break down the light from distant objects into their component wavelengths. These spectral fingerprints provide critical information about the chemical composition and physical conditions of celestial objects. In the case of GN, Z11 and Uncover, Z13, spectroscopic analysis has revealed not only the presence of stars, but also heavy elements like carbon, oxygen, and even iron, elements that form in the hearts of massive stars and spread through space via supernova explosions. Their presence so early in the universe suggests that multiple generations of stars had already formed and died in rapid succession, another blow to the long-held belief that such enrichment would take billions of years. This unexpected complexity in the chemical makeup of early galaxies points to a major flaw in our understanding of star formation rates, the efficiency of galactic evolution, and the timeline of cosmic history. Gravitational lensing, nature's cosmic magnifying glass. One of the most exciting tools in JWST's arsenal is not its technology per se, but the universe itself. Gravitational lensing occurs when a massive object, like a galaxy or galaxy cluster, bends the fabric of space-time, distorting and magnifying the light from objects behind it. This phenomenon, predicted by Albert Einstein in his general theory of relativity, allows astronomers to peer even farther into the past. A particularly powerful example involves GN, Z11, which acts as a cosmic lens, bending light from even more distant sources. Through this gravitational lensing, JWST was able to detect previously unseen structures behind GN, Z11, including even older galaxies that push the boundaries of how early light and structure could exist. In another dramatic case, a single star from the early universe was spotted using gravitational lensing. Named Earendel from the Old English word for morning star, this luminous point of light existed just 900 million years after the Big Bang. Ordinarily, Individual stars at such distances are impossible to detect, outshined by the galaxies around them, but a perfectly aligned galaxy cluster known as WHL 0137-08 acted as a lens, amplifying Earendle's light and delivering it to JWST's instruments. But Earendle's nature defies expectations. It looks remarkably like a modern star, not like the first-generation population 3 stars that scientists expected, stars that should be composed almost entirely of hydrogen and helium. This raises further questions. Are our ideas about the first stars wrong? Was the early universe more chemically enriched than believed? The myth of the Dark Ages. Traditionally, the time between 380,000 and about 500 million years after the Big Bang is known as the Dark Ages, a period before stars and galaxies lit up the cosmos. But JWST's discoveries suggest that this darkness may have been much shorter and less absolute than once believed. If massive galaxies like Uncover, Z13 and stars like Earendel were already shining so brightly just a few hundred million years post-Big Bang, then the onset of star formation, cosmic structure, and even reionization, the process by which the first stars ionize the intergalactic medium, allowing light to travel freely, must have occurred far earlier and faster than our models predict. This revelation shakes the very timeline of the universe. Einstein rings and the hunt for dark matter. Among the many predictions Albert Einstein made was the existence of so-called Einstein rings, circular arcs of light formed when a distant galaxy's light is bent into a ring by the immense gravity of an intervening galaxy. JWST has now discovered the most distant Einstein ring ever observed, designated JWST ER1. This discovery is significant not just for its aesthetic beauty, but for the secrets it may hold. The way these rings form and distort depends heavily on the mass and structure of the lensing object, including its dark matter content. By studying the lensing effects in systems like JWST ER1, astronomers can probe the invisible scaffolding of the universe, dark matter. These findings may finally shed light on one of cosmology's most enduring mysteries, what makes up the vast majority of the universe's mass. A crisis in cosmology, or a new beginning. For nearly a century, the prevailing cosmological model, rooted in the Big Bang, cosmic inflation, dark matter, and dark energy, has served scientists well. It has predicted the large-scale structure of the universe, the cosmic microwave background, and the absurd expansion of the cosmos. But now, with every new image and dataset, JWST is challenging these foundational concepts. Could there be flaws in our equations, or are we seeing signs of new physics? Might the universe have evolved differently, or is it even older or larger than we thought? Some researchers argue that we may be on the brink of a cosmological revolution, similar to the shift that occurred after Einstein appended Newtonian physics. Others caution against abandoning current models too hastily, pointing out that extraordinary claims require extraordinary evidence. The future of cosmology in the age of Webb. One thing is clear. We are witnessing the beginning of a new era in astronomy. With each observation, the JWST is peeling back the layers of cosmic time, revealing a universe that is richer, more complex, and more mysterious than we ever imagined. Whether it leads to a revised timeline of galaxy formation, a redefinition of the Dark Ages, or a better understanding of dark matter and energy, the data being gathered now will shape the next generation of theories. And perhaps, just perhaps, Webb's discoveries will one day provide answers to humanity's oldest and deepest questions. Where do we come from? What is the nature of the cosmos? And are we alone in this vast and ancient universe? If you're fascinated by the unfolding story of the cosmos and want to stay up to date with the latest insights from the James Webb Space Telescope and beyond, subscribe or follow the latest space research outlets, because the universe has only just begun to reveal its secrets.